Welcome back to Wildcat Academy. Today we're going to be discussing triangle similarity. There are three different postulates or theorems that we will use to prove triangles similar, I should say. The first one is the angle-angle postulate, which states that if two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. So it is sufficient just to have two triangles, or two angles in one triangle and two angles in the other. It's not necessary to prove the third one because the third one is automatically congruent, but the third angles theorem. So here we have, so what does that look like? Very simply, you're going to see something like one angle here marked congruent and the other one here, and you'll be able to discern in some meaningful way that a second angle, and it could be any two. These could be figures could be rotated around, but this is what it looks like. And so if this is triangle ABC and this is triangle, let's say DEF, then we can state a triangle similarity statement. Triangle ABC is similar to triangle DEF. And we have to be careful here when we write this similarity statement. Angle A and angle D are congruent, so you'll see that they will correspond, those vertices correspond in our triangle, our similarity statement here. C and F are congruent, so they will correspond in our similarity statement as well. And then we might say that these are similar by the angle-angle similarity postulate. Over here, if these had two right triangles, and if this angle was 30 and this angle down here was 60, are these two triangles similar? Well, yes, they are. Again, by the angle-angle similarity postulate, you might have to go through the process of calculating this other angle to be 60 degrees, like we did here, and then you can see that we have two angles congruent. So then you could say triangle 1 is congruent or similar to triangle 2. Let's name this one X, Y, Z, and this one P, Q, R, and then we would write the similarity statement. Triangle X, Y, Z is similar to triangle P, Q, R. Again, these are orientated in the same way. It's pretty simple to match up the vertices, but again, just make sure that when you write that similarity statement that you're attending to corresponding vertices listed in the same order. Our second theorem is the side-side-side theorem. If corresponding sides of two triangles are proportional, then the triangles are similar. So what that would look like is we have triangle ABC and triangle DEF, and so we could create ratios of their corresponding sides. So we would place 3/6 because those are their two smallest sides, and then the next length side is 8 and 16. And then we would create a ratio of 9/18. All of these simplify down to 1/2. So then we would know the two triangles are similar by the side-side-side theorem. And then we could write a similarity statement, something like, again, attending to the fact that our corresponding angles are going to be similar. So triangle ABC, you cannot miswrite the first triangle, and then you just match up the second one. Triangle DEF, and you can see that side length AB corresponds to side length DE, or angle A corresponds to angle D. I think it's the easier way. And then we would say by the side-side-side theorem, or by side-side-side similarity. All right, so look very similar in another triangle. This is one of the most obvious methods to see because you're only given sides of triangles. So we can place the corresponding sides over each other: 9/3, 12/4, and 15/5. So these all simplify down to 3/1. And we would see that the triangles again are once again similar. We could write a similarity statement, something like X. Let's do a different order here. It's, triangle XZY is similar to triangle RSQ. These are orientated in the same way, so it's pretty simple. You just go XZY, RSQ, listen to the angles, and then we might say by the side similarity. All right, our third theorem is the side angle side theorem. That says if we have two corresponding sides in two triangles, then proportional and the included angles of those sides are congruent, then the triangles are similar. So we're combining the idea of proportional sides and the congruent angles. So we can see that in this example here, we have two sides that are given, 20 and 30, and then we have two sides of this triangle that are given, 10 and 15. If we compare those, 20 over 10 and 30 over 15, that simplifies down to 2 over 1. So we can see that they are proportional. And then you can also see that we are given angle A congruent to angle D. So because of that, we can then know that we have two sides that are proportional and the angle between them, the included angle, which is here. And so let's try a triangle CAB, just to mix it up a little bit, and triangle FDE, again paying attention to our corresponding angles being listed in the same order in our similarity statement. And then we would say by side angle side similarity. In the second example, you can see once again we have proportional sides, a little switching around here in this example. So we can see that we want to place 3 over 6, and we would want to place 4 over 8. Be careful that when you see this kind of diagram that you know that which sides to place over one another, because it can lead to a false statement if you put them in the wrong order. But the smallest side will correspond to the smallest side in the second triangle, and the larger sides will correspond. So we'll place 3 over 6 because those are the smallest values, and then 4 over 8 are the next largest values, and they both simplify down to 1/2. So then we're needing either the third side or the other angle, or an angle in this case, and we would know that the vertical angle, which is the included angle between those proportional sides, is congruent because of the vertical angles theorem. So then we could write triangle WXV is going to be similar, and this is where it gets tricky. This triangle, this is not a reflection and then a dilation. This is going to be a rotation. So W corresponds to angle Z. And then Y corresponds to X. And then of course V will correspond to itself in the two triangles. So that's a little tricky there. So it goes WXV, and then it goes ZYV. And this will be by the side angle side theorem. All right, so those are our two theorems and a postulate. The angle-angle similarity is a postulate. The other two are theorems. And so let's take a look at just a few quick examples. No formal proofs, but just a few examples here. So example 1, we can see that we're given two sides. So that's an indication that we're going to be at least using side angle side or side side side. But then we're given a set of parallel lines in the picture. So we will want to, parallel lines typically give us corresponding angles or alternate interior angles. And in this case, we can see that we would have the corresponding angles congruent. That we would want to check the proportionality of the sides. So you can check 15 over 10, that's equal to 9 over 6. And those both simplify down to 3/2. So we have the sides, we have the included angle. So we can write our similarity statement. Triangle BEA is going to be similar to triangle CDE, and that's going to be by the side angle side theorem. All right, so in example 2, we have parallel lines. So these lines are parallel. Very similar figure that we had before, but in this case, the parallel lines give us a set of congruent angles, alternate and interior. You could have marked this set as well, angle B congruent to angle E, or you can mark the vertical angles here, but the point is that you're going to end up with two angles in one triangle congruent to two angles in another triangle. Therefore, we're going to have angle-angle similarity. It's just left to write the similarity statement. Triangle DEA is going to be similar to triangle DBC. And again, you can switch these letters around as long as they continue to correspond. Example 3, you can see we're given three sides in both triangles. So that's a good indication that it's going to be side-side-side similarity, if anything. Let's go ahead and try that out. We're going to put the corresponding smallest side over the smallest side of the second triangle. So we'll put 4 over 8, and then 5 over 10. We can see these are going to simplify to 1/2, and then 6 over 12. That simplifies down to 1/2. And this will give us side-side similarity. So triangle WXV is similar to triangle, see, W is between the 5 and the 6, Z is between the 10 and the 12, the corresponding pieces there. And then we will go over to the vertex X and then Y. So again, be very careful. You saw me be very careful there. And that was the side-side-side similarity. Had we not wanted to use side-side-side, just as an example, you could have also thought about this angle right here being congruent because of vertical angles being congruent, and we could have had side angle side. But I did want to see an example of side-side similarity, so that's the route that I chose there. Example 4. So we have two sides. You can see they're broken up proportionally. However, that's another video, but there is a theorem that says if the sides are broken proportionally, then these lines will be parallel, and we can set up proportional measurements to calculate there. But again, that's another video for another time. Usually a little bit deeper into similar triangles when we study that. But we're just going to stick with showing that the sides are proportional. So this length here is 6. This length here is 9. So we'll have to, let's see, place 4 over 6 and test to see if that is equal to 6 over 9. Both of those are equal to 2/3. So we have two sides proportional, but we need that other angle. Well, angle R is in both triangles, so that's a reflexive angle if we're thinking about a proof. And so angle R is congruent to itself, angle R, and therefore we would have side angle side similarity. And we would have triangle, let's see, RSQ is similar to triangle RTU. All right, so triangle RSQ is similar to triangle RTU by the side angle side similarity. Let's write that underneath. Side angle side similarity. All right. Well, that winds up our lesson on triangle similarity. If you enjoyed the video, be sure to hit the like button below, subscribe to the channel so you don't miss out any other great videos from Wildcat Academy. Leave comments below if you have questions about anything in the lesson, and look forward to seeing you guys next time on the channel.